Hey, so I figured I'd give you a quick demo of the new shell mapping stuff that I've done, and also explain the reasoning behind why we need it. Um, I've got here obviously a cube and a cylinder. They're both flat texture mapped. There's no normal mapping. In fact, there's no lighting of any kind, so that we can see the effect of the shell mapping directly, and the steps that we've taken in order to get there. So flat mapping is, yes, been with us for decades. There is a material function that ships by default with Unreal that's called the bump offset. If I go up here and quickly show you that one, the bump offset modifier basically tries to shift the texture around in the camera based on the position of the camera relative to the surface. It's a very, very subtle effect. It's essentially trying to mimic parallax as you move. It's kind of slightly a bit more visible if I do it going up and down the cylinder, but it's very, very subtle on the cube. This doesn't account for occlusion. So if I look from the side of the square, then none of these stones, as you move to the side of them, will occlude the stones next to them. There has been, since I don't know, 2004, 2003, there have been multiple attempts to improve this. One of these techniques is something called Parallax Occlusion Mapping. This is one of the first material functions that I added to Unreal, and what it basically does is a ray trace along the surface. So it takes a ray from the camera, intersects it with the height field that you specify, and as you see, as you get close to the surface, the stones begin to occlude each other. Also, as you move across the surface, you get a nice feeling of parallax. There's no geometry there, it's just a flat surface. The same is true of the cylinder, so I mean, it's a lot more pronounced on the cylinder. If I go up and down, you can see everything shifting. Now, this suffers from a bunch of problems. The first is that you get, because you're tracing into the surface, you're tracing below the surface, along any edges, the ray just keeps going and going. So you get this nasty sliding effect as you rotate around these surfaces. And also, as new surfaces become visible, you can see this face here, you can see those stones becoming visible as well. And if I get to a very close angle, you can see it. It's basically ray tracing off into the far distance. It's pretty distracting, and there's a bunch of cases in texturing of real-world models where this looks pretty awful. The second issue this stuff has got is that there are no silhouettes. Right on the edge, it's still a flat edge. Now there's a very simple trick to fix this, and it's one that we've implemented, and it basically says if the texture coordinate as you're ray tracing goes outside of the range 0 to 1, then discard the pixel. You can set this up in the material function, and when you do it and recompile, you get this, and it looks pretty cool. You know, it's like, oh wow, this has got some potential. And generally, when you look on websites that show off their silhouette clipping, this is the kind of stuff that they show off. This again, though, suffers from massive problems. The first is you still have the sliding effect. It doesn't get rid of the fact that you're tracing under the surface. The second issue is that it only works from one side. So you can see here there's no silhouette of the edge from this point of view. And the third problem is that it's not something that you can generalize. So it only works on textures that don't tile. So, I mean, we do have specific options that allow you to turn it on and off for specific axes in the texture. but this is a great example of where it doesn't work. I mean, the cylinder is tiled around, and on this line here you can see it's doing its silhouette clipping, and obviously it's getting it wrong. It's like somebody stuck a big black card in the middle of it. The edge movement is actually a lot more pronounced on the top of the cylinder here. If I slow the camera down a bit, you can see as I move through, it's revealing more and more and more. It's very, very likely that you will get a game asset that can be textured in this way without showing artifacts. So I went one step beyond this. I tried to figure out some kind of technique that would be usable in all scenarios, and I came up with something which is actually pretty cool. Essentially what it does is it bends the ray from the camera in texture space. And if I apply that here, what you'll see now is that you have something vaguely resembling a silhouette on the outside, right on the edges. It doesn't have any of the issues with tile textures that the previous technique does. Unfortunately, again, this suffers from a bunch of issues. The first is that because you can't ray trace around the back of the object, you'll see right on the edges that it's almost as if the silhouette appears through a black card, almost like there's a net curtain behind it. It's a very, very subtle effect, and there's a specific value which you have to tweak in order to reduce the effect of that curtain. Now, if I ramp up that value to something pretty high, then you can quite clearly see the clipping, and you have to be very, very careful how you treat that, how you select that value, in fact, and for each specific material. Again, you know, it doesn't get around any of the limitations of parallax occlusion mapping, and as you've noticed, there's also this nasty black issue where it's kind of incorrectly detecting silhouettes when the camera gets very close to the surface. All in all, you know, I mean, parallax occlusion mapping is pretty much a dead end. It's way too fiddly, and it's very rare that you actually get game assets that can use it. Which is why, I mean, this was invented what, 10 years ago. Various people have improved on it and added their own versions of silhouettes. It's typically why you don't see it in general release in video games today. So that was the motivation for shell mapping, and if I quickly fly up here, I can show you the final implementation. So this is shell mapping. It's essentially pretty similar to parallax occlusion mapping. I'm doing a complete ray trace in the shader. You can see you've got the nice parallax effect of all the stones. You can also see that you've got proper occlusion of all the stones. Additionally, the silhouette doesn't break down from any angle whatsoever. The silhouette is always there. And it just works. I mean, it's if I go over to the cylinder, you can see the same effect here. There's no nasty artifacts around the edges. It looks as if it's a solid model, but again, you know, these are all flat surfaces. It essentially works by ray tracing prisms. So I mean, this is a lot more expensive than parallax occlusion mapping, because the first step that it has to do is it has to take your source mesh and generate a bunch of prisms on top of that source mesh, and it's those prisms that it ray traces into, and that explains why you don't get any edge issues or you don't get any silhouette problems. This edge here purely exists, I mean, you know, all this smearing purely exists because the source mesh I'm using has smoothing turned off for these edges. So you've got one bunch of normals pointing up that way, and then one bunch of normals pointing into the camera. If those vertices were welded together, then you would get a nice smooth corner, just like you would on the cylinder here. So it's pretty expensive, but it should. I'm on a 660 here. It's about 400 or 500 instructions, and it's handling it pretty well. I mean, there's a bunch of big optimizations that can be done to half the cost of this. On top of that, the next stage in making this even better is that we're not actually restricted to putting a height field on top of these anymore. We could use a three-dimensional texture. So we could take any random mesh that we want, be that a grass mesh or some kind of tiny foliage mesh, convert it to voxels, and then tile it across any surface like a tree. A bunch of other improvements could also be made. I mean, this stuff could be stuck on animated characters. We could animate the movement of the height field or the voxel map itself. And the really cool thing is that it integrates with the material system that we've already got. So if you use this for modeling hair, you can automatically hook up the anisotropic shading model to it to get some nice effects. And that's it. It's all checked in. This test map is there if you want to go and have a fiddle to see what it's like. Yeah, let me know what you think.